Welcome back, everyone. I am here to address some questions from the webinar, Enhancing Safety, Understanding Updates to API RP 752, 753, and 756. The first question is around internal environments. Is there example calculations methodology for determining rate of oxygen depletion, carbon dioxide rise, temperature, humidity rise during shelter in place? And in essence, carbon dioxide and oxygen concentrations will change over time in a shelter in place building or toxic refuge due to occupant breathing. And it can be calculated from things like you would use the building volume, building leak tightness, number of people in the building, and level of activity in the building to determine the oxygen consumption rate and the CO2 generation rate, which are linked together. On the other hand, calculating carbon monoxide concentration inside, say, a fire refuge or shelter-in-place building due to infiltration of combustion products is quite difficult and would strongly depend on the combustion conditions, and again, hard to predict. So it is recommended to set acceptable criteria for these internal environment conditions and monitor indoor conditions and instruct personnel to evacuate when you reach above this acceptable criteria. The next question is on how is personnel competency defined? And so personnel competency requirements are defined in APR RP 72, 73, and 76, and really talks about areas of competency, right? So where do people need to be competent in? And things like the application of the methodology being employed, application of owner-operator siting evaluation criteria, hazard identification, fire modeling, explosion modeling, frequency assessment, etc. So those are all examples of areas of competency that a personnel would have to perform these siting evaluations. However, it does not define, what is a competent level in these areas. So what, specific training or experience or history, that person has to have. So that is, again, up to owners and operators to somewhat define and manage that specifically. The next questions are a little bit about the hours in a building around those topics. So one question was around the 40 hours per week. So this is related to the risk siting evaluation criteria. And does this mean that all buildings with less than 40 hours per week would have to be considered equally, even if they're only occupied much less than 40 hours per week? And so a couple highlights here. One is that let's see here. So the first step is that, siting evaluation criteria for a risk-based approach shall address the risk to the building occupants as a group, which is the aggregate risk, and the risk to an individual. And then for individual risk, the recommended practice says that for a portable building or tent intended for occupancy, to establish the individual risk, this study shall assume the portable building to be occupied at least 40 hours a week by an individual for the entire year, no credit shall be taken for cases where the building will not be used or located at the site for less than a year. And so, yes, for individual risk, there are different metrics of individual risk. There's building individual risk, maximum individual risk, worker individual risk, things of that nature. And building individual risk is just assuming one person 24/7 in the building. So continuously. So the hours per week doesn't even matter there. So you are already comparing every building on a level playing field. For maximum individual risk, I would say this language is saying that even if the maximum uh, hours per week in the building is less than 40 hours per week, so that's the maximum time someone spends in that building, you still need to use 40 hours per week. And I would say, there may be some questions on, if it really is a lot less than 40 hours per week, a couple hours a week, maybe there's a question on whether that building is, intended for occupancy or not, potentially. So if it's an unoccupied building, obviously this criteria doesn't apply. But once a building is intended for occupancy, and you have a risk-based tolerance criteria, both individual and societal risk, for individual risk, you cannot assume that the occupancy is less than 40 hours a week by one person for the entire year. The other question, a little bit around occupancy, is can we say that occupancy less than 48 hours per day, maybe that's per week, for a permanent building makes it fall under non-occupied building? And my guidance there is that there is no specific criteria or guidance about the number of hours that make a building occupied or unoccupied, or intended for occupancy and not intended for occupancy in these recommended practices. Maybe years ago and editions ago, there was some guidance, but that has since been removed. And in essence, something like, again, 48 hours, if it really is 48 hours a week or something like that, that's, probably something that is intended for occupancy, that type of number. But again, there is no guidance on the number of hours, and it's really based on, the building function. It's much more about the building function. And even a building that hardly has any people in, but then has a lot of people for a short duration for a meeting or something like that, that's still intended for occupancy. A building that really has no occupancy except for during emergency response or something like that, right? And becomes highly occupied, that's also intended for occupancy. So it's not specifically around number of hours in a building, but I will say something like 48 hours per week, if that's the question, is quite high, especially for at least, if one person was in there. Another question was, I think, on the frequency of revalidations. And do most companies do FSS security revalidations on a 5-year frequency? And yeah, from the webinar, there is a new section around revalidation and periodically revalidating your facility siting studies. And it does not specify a frequency of revalidation. My guidance and what I typically see with clients is that, one, studies are updated, really continually, right? Depending on the management of change and different changes on site that would change the facility siting study and the results of that study. So, as changes to the facility happen, those changes are evaluated if they're going to affect the facility siting study. So studies are often updated, almost yearly or something like that, right? Or just on a very continuous basis. But in addition, I do see clients even above and beyond that, then revalidating their studies on some frequency too sometimes, and often that is most often that is a 5-year frequency aligned with the PHA revalidation. That's the typical PHA revalidation schedule, is also on a 5-year basis, and that's where facility siting study falls under an OSHA PSM standard. So the next question is on, can you expand on the logic around the decision about why it's not acceptable to use a risk-based approach for occupancy of non-essential personnel? I would think that if the explosion potential is extremely low, or if the vulnerability level of the building is low, then the risk might be acceptable. And so, really, the logic on not allowing a risk-based approach for citing of non-essential personnel is really around that, because they're non-essential, they really don't need to be located very close to the process. They don't have to be right there for operations and emergency response and things of that nature. So, think of admin or accountants or personnel like this, HR or something. So, in essence, why allow them to potentially be very close to the process? And when you specify a risk-based approach, right, the recommended practices, they say you have to establish individual and societal risk tolerance criteria, but it doesn't say what that risk criteria needs to be, and specifically, like, how you exactly have to calculate it, what frequencies, what scenarios. All of that is left up to the owner and operator. So it's very loose, and technically, potentially, owners could say, okay, I have a risk-based tolerance criteria, and now non-essential personnel could be really close to the process. And so, in a lot of ways, I think this is almost a line in the sand saying, if you're non-essential, there's not a reason that to be close to the to be that close to the process. So, we're going to establish that kind of distance of at least 330 feet, say, from process area congestion, as a minimum standard. So the next question is on, does the conservative interpretation of the additions relative to non-essential personnel include toxics? And the answer is no, it does not specifically include toxics. So that obviously the zone restriction boundaries and the citing of essential versus non-essential personnel, it is around fires and toxics specifically. Fires and explosions specifically, and explosions, VCE and any non-VCE hazards, so TNTs, furnace firebox, BPVs, things of that nature. But it does not have to account for toxics, and that is the toxic hazard, and the citing values for toxic falls under then the consequence or risk-based approach. So again, the essential, non-essential personnel citing does not consider toxic hazards. The next question, please. How could you remind us the definition of maximum credible event? So a maximum credible event is defined in each of the RPs, and it is a hypothetical explosion, fire, or toxic material release event that has the potential maximum consequence to the occupants of the building tent under consideration from among the major scenarios evaluated. The major scenarios have a reasonable probability of occurrence considering the chemicals, inventories, equipment, and piping design, operating conditions, fuel reactivity, process unit geometry, industry, incident history, and other factors. And each building or tent may have its own set of MCs for potential explosion, fire, or toxic material release impacts. Moving on, is there a minimum expectation for air tightness for a toxic refuge, or is there any guidance on tightness requirements for a toxic gas refuge? And the answer is there is no minimum expectation or requirement for the air tightness of a toxic refuge. In essence, I will say that really how this should be defined is on your consequence or risk-based tolerance criteria, right? So really this is highly dependent on the toxic hazards on site, how many there are, what the toxic materials are, where they're located, the conditions, the process conditions, the inventory, and then the location of the building or toxic refuge or refuges on site, right? So the more toxic hazards you have, especially of highly toxic materials, the more material containing it, where the frequency is going up. Really what that means is the greater that leak tightness is going to be. So it's going to need to be, quite leak tight. Whereas if you have a site with very few toxics and you still want to have a toxic refuge, it doesn't have to necessarily have that same level of toxic of leak tightness to have the same protection level, right, and the same consequence or risk results. So again, really this should be the definition of what the requirement is on leak tightness is variable and should be assessed at each site. So the next question is, in the event that safe evacuation is not possible, could the fortress option be safe against a jet or pool fire event? And yes, the fortress is an option as a fire refuge if safe evacuation is not possible. And also, the fortress has had extensive testing on it. The concrete panels and doors have been field tested for a 1/4-inch propane impinged jet fire for 30 minutes, with indoor temperature remaining below 100 degrees Fahrenheit. And the joints between concrete panels were also tested for a 1/4-inch propane impinged jet fire for an hour, and temperature remained below 100 degrees Fahrenheit and did not produce smoke or toxic combustion off gases. So yes, this is definitely, these type of buildings are definitely a potential refuge. Next question is around building leak rate during shelter in place due to a toxic release, and the amount of time people within the shelter seem to be key factors in assessing safety. Why are these should instead of shall? And in my opinion, the answer here is that, and I don't disagree with you at all, but in my opinion, in the previous version of the APIs, and specifically probably API RP 752, it had these requirements were a may. It's not even a should. It was you may evaluate a toxic shelter in place based on the amount of time people are within it and the duration of the toxic release. And so the next step, to make a change, say from may, is to go to should, and then from shoulds to go to shall. And so in general, that's the step change that takes place to allow industry to kind of get prepared for these changes, and know that they may be coming. So a lot of times, should on subsequent revisions of the RP, shoulds, they may change to shalls, right? So it's going from may to shall was maybe too big of a step change here for all companies at this time, and it's a should. But again, those are clearly important things, and if you have a toxic refuge, things that you would definitely want to assess to make sure personnel are safe in those buildings. The next question is, I have heard different views regarding using plastic film on windows to prevent shattering of glass in events of overpressure and harming occupants. Some believe that if this is done, the whole window could be blown out and can hit an individual inside. This could be worse hazard than glass fragments. Do you have a view on this and any testing that backs this up? So when you are looking into this, it is important to consider the response of any blast-loaded building. It's essential to understand the building components, how the building components are supported. And this guidance is consistent with APR RP 72, 7.6.1, which states conventionally constructed buildings is limited by the capacity of the connections. So using window upgrades as an example, the reactions from the glass need to be transferred into the window frame, and the reactions from the window frame need to be transferred into the building structure. So if this is done properly, that film could be transferred to the frame, and the frame could be transferred. The reactions from the frame could be transferred to the building. So testing completed at the BakerRisk shock tube demonstrates how not adequately transferring the reactions into supporting elements can lead to failure. For example, if the window film upgrade is not anchored to the window frame, the window glass can become a debris hazard. If the window frame is not anchored to the building, the window frame can become a debris hazard. So it is all linked. And if you don't link one to the other, then you could present a different hazard or worse hazard. But if you link them all together properly and have anchored them to each other, then it can be a benefit. The next question is, what updates, if any, require immediate review versus review during MOC and revalidation of the study? And my response to this, or my guidance around this topic, is there are typically pretty obvious things that I would say are going to require a review or update of your facility siting study. So if you add a new occupied building on site, or you add a new process unit, those are things that are clearly going to change your siting evaluation, and you just know that you're going to have to update your siting study. On the other hand, there are smaller updates, probably, or different things that may be more of a question mark, and usually that an example of that could be something like you add a substation on site, and that substation is unoccupied, but it's elevated, and now you have an area of confinement if a flammable release can go under that building, reach that building and go under it, that now you have worse explosion impacts in this area. And, similarly, you could add a unoccupied warehouse or storage area that's kind of open, has overhead doors that are open or openings that are clearly open that could allow flammables inside. Again, unoccupied building. And really the question is, where are these buildings, right, being placed? So if that substation or that warehouse is in close proximity to other buildings, right, other occupied buildings, permanent, portable, or tents, then it definitely could be changing the consequences or risks to those structures. However, if there's really nothing in the vicinity of these things that are occupied, there's several hundred feet away, then it's probably not changing anything to those occupied buildings and portable buildings and tents at that time. So that you may be able to rule that out and say we don't need to update the siting evaluation at this time for this change, but it's something to flag and put in our next revalidation study when we're combining changes together, for example. And another example of some things to put in your revalidation would be things like updates for methodologies or software changes, right? That may be time. You wouldn't do that in every single update and stuff just because a methodology changes, but at that 5-year revalidation, you take into account changes in industry based on testing and research that have changed methodologies or software over time. The next question is on, will the ASCE for design of blast-resistant buildings in petrochemical facilities be updated to reflect the changes in API RP 752 and 753? And BakerRisk actually does have a member on the rewrite committee for this book, and it is the understanding of BakerRisk that the design of blast-resistant buildings and petrochemicals, which is currently being revised by the ASCE Task Committee, will not include specific references to the latest versions of API RP 72, 753, and 76. However, blast-resistant design principles discussed in the ASCE reference can be used to address the detailed blast evaluation requirements of the API RPs. The next question is on, can you elaborate more on risk-based studies and if there is any acceptable limit at all? Again, the API RPs 72, 73, and 76 don't specify a specific risk tolerance criteria for individual or societal risk, and lets the owner, operator, and companies determine and establish their own risk tolerance criteria. But there is a lot of guidance out in the public on risk tolerance criteria. So there are lots of guidance by different countries. So there are countries out there that establish and set risk tolerance criteria for owners and operators. One example is in the UK HSE. There's a document on reducing risk, protecting people, commonly called R2P2. So you can, again, look this up and find guidance on risk tolerance criteria, but there's others out there too. And it does depend on whether you're talking about individual risk, say geographic individual risk for offsite. A lot of countries have land use planning guidelines on what risk tolerance criteria for different types of land use planning out there. There's also, FN curve tolerance criteria out there, things of that nature for maybe on-site or off-site. So, and there's lots of of papers from conferences and in journals around risk tolerance criteria as well. So yeah, I think there's lots of resources out there, but there is not one, especially in the US, there is not one acceptable limit. And it really is a range because it's not specified by the government. The next question is, when is it expected that we follow these guidelines, or is there a timeline when the changes are to be implemented? And so, I have not specifically heard about a prescribed time to comply with a revised recommended practice. I am aware that API will be revising the Process Safety Site Assessment Program, PSSAP, protocol in the coming months to include these updated recommended practices, and API will transition to assessing against those updated protocols in June 2024. So in essence, they're giving industry 6 months to digest the new and updated requirements. But from a practical standpoint, I would say the next time a facility siting study is revalidated or changed, or a change is made to the facility, maybe a larger change, then it does make sense to use the latest versions of the RPs. And with that, I think that's pretty much all the questions. Thank you all.